Very good evening, and tonight's video is going to be something short, frivolous and fun, and it's something that I've already built but I'm modifying, changing, and generally just I got bored with the way it looks, so I'm changing it. Now on the bench you can see there's a mains plug and a little box that says high voltage on the back, but all this is a standard capacitive dropper. And what I've already done, these originally were tungsten bulbs, and I actually took the tungsten bulbs out and changed them for LEDs. Now what I will do is I will get the test meter and plug that in. As you can see there's a couple of ones that aren't lighting because the current is limited quite a lot. Now, for example, this one isn't lighting. That one is. It's a mix of blue and greens because that's what I had. That one's not lighting either. And it's actually too lower power, too lower current draw for this meter to even detect off the mains. Now what you could probably see is on there is a mark to denote the positive, and also on the little holders which just pull out there's also a mark to denote the positive. So what I plan to do with these is I've got my box of larger LEDs and I plan to actually change the blues and the greens for pink, orange, yellow and red, and just go through, and these are larger LEDs as well, so just to make some variety of colours, because I'm bored with the blues and the greens. I'm just going to change them for different colours. If I show you how the first one does, and if I open the box of LEDs and just pop it out, we've already popped this out, as you can see. All I have to do is unbend these ends like that. Take the LED out, drop it in there, and I'm going to go with the first one. Now these LEDs have actually got the same spacing as the 5mm ones, the same lead spacing. So we put the longer lead, which is the positive, in the line with the black line there that I've got on the holder. Fold it over, fold that side over, get the snips, cut it off nice and flush. Oh, don't drop it. Again this side, cut it off nice and flush. Like that. Just bend that back up, make sure the positive lines up, and put it back in that socket like that. Let me change the LEDs and we'll see where we go from there. Back in a little while. So they're all changed over now, and plug them in. Now we've got a full circuit because everything is lit up. Let's make it a bit more visible to you by turning off the bench lights. And there we go. We have a little bit of a pattern. Now these being the larger straw hat types, they generally tend to focus the beam forward. I'm going to turn the light on so you can see me again. Whoa, that was a bright flash, wasn't it? Now, if I had the concave top ones, they'd actually spread the light out sideways. Again, we're still not getting any reading on the meter, and I don't know if the camera's picking that up at all. It's showing 0 watts, 0 amps, mains voltage of 240.3, 0.4, and 0 power factor, because the capacitive dropper is actually not using very much electricity at all. it's quite a small value of capacitor. Now the original capacitor that was in there, I know I changed for a different one, purely to reduce the current to the LEDs even further. I could brighten them up and get my cutters. I will cut this open and just show you what is actually in the box, should I be able to get it open. Come on, or did I glue it? I might have glued it shut. Oh, there we go. Right, yes, I changed this capacitor here. Let me just make sure the other one is discharged, because this will be a bit of a zap if you get it. Right, yeah, that's discharged. So this is the 400 volt. There's a 223 in there at the moment. This circuit is actually very, very standard. You have your mains coming in. You've got your drop-in capacitor here. The mains comes in, goes through the drop-in capacitor here, which is these two terminals here. It also has a resistor across it, this one here, which is actually a 47 with 470k resistor, and that's there to discharge this capacitor when the power's off. That all then goes through to the bridge rectifier, which is these four diodes here. You then get a little bit of smoothing when it comes out of the rectifier. Comes through this resistor here. Here's your smoothing. And then you've got your main current limiting resistor here, which is on the positive line there. And really, it's as simple as that. It is a very basic capacitive dropper circuit. The actual LED current is dependent on this capacitor here, and the size of this capacitor determines how much current is available to the output side of the circuit. Okay, so we've already gone through the circuit on the board. I'm just putting this picture up to show, first of all, the circuit diagram, and then the formulas at the top are to work out your current in your capacitor 1 and how much you're likely to get distributed across the LEDs. The other component values are there, which are what is in the dropper that I've used. You can obviously change those values to other values. A common one I've seen is R1 being 1 mega ohm. It's there not only as a discharge, but it also does prevent massive spikes of voltage damaging C1. R2 is your discharge capacitor. C2 is smoothing. If you want it smoother than flickery 50 hertz, 60 hertz mains, depending on what your line frequency is, you can up that capacitor. It's purely up to you. That's really about it. The only other warning is C1 should be an X2 type, or an X type at least. You don't want it to fail short. In the UK, if you get a short circuit on that, you've effectively got 32 amps of line current going into your bridge rectifier. So there are 40 LEDs, and each of them, are looking for between 2 and 3 volts. So let's measure the actual output voltage that's coming out of this particular device. So hopefully I can get across there. So 83.8 volts DC going through 40 resistors. 40 diodes. What am I talking about resistors? They're 40 LEDs. Works out just a tad over 2 volts per LED, which is well within their ratings. Obviously, the current limiting resistor at 470 ohms will have an effect on that. Let's see, what's that actually dropping? about a volt. So if you took that out, it wouldn't give too much voltage, but obviously that is limiting the current somewhat. And that is also a 1 watt resistor, just to provide all the voltage for all of this and limit the current in the correct manner. So there we are. We have a set of tungsten lights converted into LEDs with a little capacitive dropper. I did wonder about putting this capacitor into it, but then I thought, we're already at the lower end of the scale. Do we need to go any lower? And I thought, no, there's no real reason. Putting a large capacitor in would give me more current per LED. The voltage should stay roughly the same, and that's what we want, really. We don't want any more voltage, and we don't really need any less voltage. More current would make them brighter, but I don't really want them too bright. They're just there for a gentle nighttime glow, really. So that's what we have here. Thanks very much for watching, and hopefully we shall see you again very soon. Please leave comments. If you like what you see, let me know. If you don't like what you see, let me know. Try and answer everything. And be interested to hear your thoughts on this little project. Thanks very much for watching. Hope you've liked the video, you've subscribed, and you've clicked the bell icon. If you haven't, go ahead, do it. You know you want to. It's all good fun. You just really feel good about hitting that like, subscribe and bell icon. Many thanks for watching, and we'll see you again in the next one. Bye for now. Don't forget